is leverage RISC-V to win your success. The presenter is Mr. Frankwell Jin-Ming Liu, CEO and Chairman, RISC Technology Taiwan. 日本語でやります。次の講演タイトルは RISC-V を活用して、成功を勝ち取るです。ご講演者は台湾&テクノロジー CEO and Chairman のフランクウェル・リン様です。So, Frankwell, would you please start?
Okay, thank you. My subject for today is leverage RISC-V to win your success. Today, in the world, there are three major instruction set architecture standards. We know x86 from Intel. We know ARM. Now, RISC-V is the third worldwide leading infrastructure for ISA. It is inevitable. It can do everything. So let's try to explore what it can do. It leads on innovation because its nature, its characteristic for aiding instruction set by yourself. It is flexible. It encourages innovation. So there's a terminology called domain-specific extension that you can create because you have a domain knowledge by yourself. You did that kind of innovation by software or hardware before, but now you can do that in ISA style. Name it RISC-V. And RISC-V is leading in platform standardization. The terminology is called profile, which I will cover it a little bit later. So in the future, different kind of application platform, RISC-V International Association will create kind of standard platform. Then we already know RISC-V International Association has leading the world to build a contributor culture. So there are thousands, or say tens of thousands, engineers worldwide to contribute their knowledge, their enthusiasm to this RISC-V ecosystem and infrastructure. So RISC-V is rapidly building the strongest ecosystem. I think Wei Han also mentioned that earlier for this. We have same slides, so I don't repeat it. Now, moving toward the part of Andy's, I bring three subjects today. The first is AI machine learning. Second is application processor. The third is automotive-grade processors. In this slide, let's first focus on the right corner. This corner. For AI and machine learning. This graph shows you that the customers already use Andy's RISC-V core to do their chip development for AI and machine learning. So, such as compute in memory, such as a photonic type of AI, and data center AI for various kind of algorithms like a CNN transformer. All these customers, they already leverage Andy's RISC-V core to do AI acceleration, to expand bandwidth and expansibility. Today, there are several on-the-shelf Andy's RISC-V cores for this AI machine learning application. So the major one is AX45MPV, which is an 8-core clusters with high-speed vector memory interface. It comes with the leading vector length, 1024-bit. So it comes with many of data type, because in the application area, different kind of customers, they request a different combination of data types, from integer to floating point. Now we also add a bfloat 16 to this portfolio. And going forward, we will have AX46 MPV very soon, because our customers requested to extend 8-core cluster to 16, more features like matrix manipulation, and we will extend the vector length to 2048. So this is our commitment to bring it to an even higher grade. There's a terminology RVA23 here, which means that the profile RISC-V International is leading to build. And RVA23 is a profile for application processor. So we will cover that later. Some details about AX45 MPV. It's at stages in order dual issue scalar unit. It comes with a vector unit in the processor integrated as well. Some features I already mentioned, so I skipped the part of high bandwidth vector local memory. And comes to the ACE, which is Andy's custom extension. And let me use another chart to explain. But you know, ACE is a automated tool for you to add your custom instruction you create by yourself, but it automatically produces RTO, produced tool chains for you. And we also have S for RVV. That means that the instruction set type can be vector type. Now, for AI, because this part we talk about AI, we have different kinds of ecosystems aimed for AI. This one is especially for edge computing. So let's talk about how to bring the hardware, software design for AI edge computing. Now, talking about the NM models you can have from open sources, how to bring them down to the hardware and run them. In Andes, we provide the cores in the bottom. You choose them for AI application. Then above that, there's a LLVM compiler with automatic vectorization that comes with computer library, NN library, and an ANDOA driver. Then there's NN pilot, and this provide. No matter you create that by C code, or you generate NN models with our middleware, they can run LLVM through NN inferencer engines, TensorFlow Lite, or TVM, or directly by C code. Then ACE, like I said, you can add the custom instruction to your processor chosen from Andes on the shelf RISC-V cores. So in a way, running NM models in our AX45 MPV has shown that more than 93% of runnable of images, text, video, audio domains in AI software stack. And the others can be created as well. And that is the way to run TensorFlow and in different algorithms such as transformer. A little bit the detail of an library. It is optimized for RISC-V DSP or RISC-V Vector processors. So no matter you run SIMD or vector instructions, there are more than 170 functions created in this library for 8 categories from activation to softmax. And certainly they are all running on Andy's cores certified. Now, another ecosystem is a scalable and heterogeneous architecture TensorFlow Lite. On your left part, that is a controller cluster in which we propose you to use the application processor AX65. I will talk about that later. And the right part is the processing element that we strongly suggest that you run AX45 MPV or future AX46 MPV. So they are scalable and heterogeneous architecture, and they co-work with each other. So control and compute, they are running in parallel. And this already help customers to give them design examples. So we will help our customer to learn how to design this kind of PE for AI application. In this example, we leverage AX45 MPV to add the hardware deep learning accelerator. So we can extend computing power. We can extend data movement efficiency because an ACE streaming port has been designed here. And then there are extra control signals extended. So this kind of ACE streaming port has been adopted by several world-leading customers. One example is Meta. Meta already announced their MTIA for 2 generations. Today, if you have a Facebook running on your mobile phone or IG, you use them every day, then you certainly use Andy's RISC-V core vector processor, scalar processor, serving your data streaming needs, because those chip has been deployed to Meta's data centers. Next, I'm going to talk about application processors, and the focus is actually Android. Earlier, there is audience asking what is the progress of mobile phone application for Android, such as RISC-V core. Andy's work on this for a long time. Personally, I work in RISC-V board long time to push this kind of trend. Today, we already have on the shelf X65 is a base for application processor. And we are working on X66, which is an advanced core based on X65, higher performance, bring the spec integer 2K6 at 25 per gigahertz to more than 9.5. Now, we will add RVA23, which, like I said, is the profile for application processor for RISC-V. And then we will bring hypervisor, AIA, IOMMU, IOPMP to this core, because that is actually the requirement from Google that to run, for example, virtual machine, you need a hypervisor and so on. So AX66 can be available by first quarter of next year, and it is designed to run Android operating system. And certainly, we have a higher performance AX67 on the shelf, because RISC-V International is preparing RVA24, which might be for a server or a data center kind of profile. So this kind of application processor in line, we propose to our customers. They may apply them for mobile phone running Android system, or they may apply them for different kinds of application for application processor in the applications like Android TV, like watch or wearable devices, or even appliance, or in the future even for automotive. And this has a project called Cusco that will bring the performance from AX65, 825 to higher, like 20. So a little bit AX65 information is out of order application type of RISC-V core. It is 13 stages, 4-way, and 64-bit out of order processor. The cluster currently is 8 cores. Okay. I will skip other details, but let me come to the part of performance. Currently, with 5 nanometers simulation by TSMC's data, it runs up to 2.6 gigahertz. At that end, the spec integer 2006, it is 825 per gigahertz, which is the best in this level cores. We compare that to Cortex A75 and A76. The area is rather small, like 70% or even half of CA76. The spec integer compared in this table, you can see if we check per area performance, AX65 leading in this parameter. So, like I said, Andy's put very much effort to bring RISC-V to Android application. In the future, or for now, we already have some breakthrough and achievement. And certainly when AX66 is available, in fact, we are calling for early adopter customers that can cooperate with Andes to enter the area of Android mobile phone chip design or Android TV chip design. So if you are interested, please come to us. Now I'm going to talk about our solutions for automotive grade processors. The automotive MCU market is fastly growing. Like in 2024, the world automotive microcontroller market is in the size of US dollars 10 billion, but in 2029, it will grow to 16 billion. The per year growth rate is like 9%. So the total number of MCUs in 2024 is forecasted to be 5.7 billion, and it includes 8, 16-bit, and 32-bit. But we do see that more and more 32-bit CPU will be there. So we also put very heavy-duty investment in get NDs certified by ISO 26262. I'm talking about the company design flow. So by 2020, December, the company has been certified as a company that can develop SLD type of CPU IP. And the certifier is SGS-TUV. And we also get DAX logo. Now that's a design flow. Then we put our investment in developing the cores for SL compliant. So up to today, we already have 2 products, which is 5 stages pipeline core N25F SE and the D25F SE. In between, the difference is there's a DSP, RVP, ISA for D25F SE. So the performance is per core 3.57 per megahertz core mark and 1.9 D-mix per megahertz. And they are all both certified already as SLB. Now, the part of SLB certification, when you take a look at your vendor's data, you have to be very careful because, for example, this is a full scope for processor. You need to get certified for 26262, part 2, 4, 5, 8, and 9. But we know some vendor, they only get 2 of these 5 categories certification, and they claim that they get certified. So you have to be careful with that, because when you talk about automotive, it concerns a human's life. So N25 SE has been applied by our customers in display, touch, driver integration, in camera sensors, in cabin radar, in automotive microcontroller, in vehicle storage. Part of the customers, they are willing to disclose their name, so we put their logo here, but part of the customers are not yet ready to disclose their name, so their name is not disclosed. Now, the first SLD type of automotive grade processor NDIS brings is a D45 SE, which is a 8 stages superscalar high performance core with the performance 6.12 core marks per megahertz and 2.96 Drashstone MIPS per megahertz. And it's under certification now. We expect to have the certificate by this quarter. And when we promote this product, it will be SLD, but we will also support SLB. So there's another product under developing, and we plan to send for certification very soon. This is D23SE. It is a three-stage pipeline performance-efficient core with 4.55 core mark per megahertz and 2.0 and above threshold mix per megahertz. So it is expected to be certified by Q1 next year. And again, we will do SLD certification, but it will also support SLB. So talking about all these 4 cores to be supplied or are already on the shelf, what they can do for N25F or N25SE, they are a mainstream processing unit you can leverage. But for D45SE, that is 8 stages, which can do mission critical control. And for D23SE, that is a low power and for security application. So with that external safety mechanism, STL is also supported. And for the SLD course, we do that with a dual core lockstep. Summary, RISC-V for industry is quite new, but it's already one of the 3 standards in the world. It can help you to win success because innovation is supported and encouraged. In Andes, we provide RISC-V Core's IP to help you to gain control in building SoC design. In fact, our commitment is to build the world's most complete RISC-V Core portfolio. I think we already lead in the CPU IP of RISC-V community. And we will like to enhance that, strengthen that, and provide our support to you. No matter you are from industry or from academy, you are welcome to approach us. So we have a booth just near the door. You are welcome to come to visit our booth, come to see our explanation or a demonstration, and do Q&A. So that's my presentation. Yeah. Now it's time for Q&A. Thank you.
Thank you, Frankwell. So now the open for the discussion. So we have 34 minutes. So please ask questions. So,
no?
I don't think so.
All right.
I have questions.
Okay.
So in my old memory, Andes was started as a small embedded core region and expanded to many application markets.
Right.
So now the top what is the top focus area? Automotive?
Mm-hmm. Automotive. AI is the #1 contributor to our revenue. In fact, 40% of the company's revenue comes from AI.
Okay.
Yeah.
So your CPU core with AI enhancements or accelerator is widely accepted by customers.
Right. It's already in the application in the chip. We ship many more.
Okay. So I remember you mentioned the Meta data center.
Right.
So my understanding is Meta, Facebook has its own data center.
Yeah.
And of course, it consists of many Linux machines.
Right.
So maybe some AI accelerator card is installed and used, and the card uses your IP.
Yeah.
Is this my understanding?
Yeah,
Okay?
it's deployed and in mass production.
Okay.
Okay. Yeah.
Thank you.
Okay.
他にいかがでしょうか? Any questions? ではないでしたか。じゃあ、
Okay,
let's
if no,
close
yeah,
the
thank you.
presentation. Thank you very much.